In this video, we'll be going over the trigonometric law of cosines. It is used to solve an oblique triangle or triangle without a right angle. It can be used when given all three side lengths of an oblique triangle or two side lengths in the shared angle of the triangle. I've listed on this slide to the left all forms of the law of cosines to solve for each unsolved side or angle. So now let's prove the law of cosines. To help illustrate this proof, I have a triangle with angles designated with a capital A, B, and C, and side lengths directly across from those angles designated with a lowercase a, b, and c. We'll be drawing a line in the center of this triangle to make two right triangles. This line is perpendicular of side C and connects at the point of the angle of C. Now we will overlay a x and y axis over the triangle with the origin being at the A angle point, so it is at 0, 0 here. At the B angle point, we will designate it with an x length of side length C of the triangle and the y height of 0. At the point of the C angle, we will designate this with a purple x and an orange y, because these values are not yet known. Notice that the y and x make up the height and length of one of the right triangles formed by making a line connecting the C angle point at a 90-degree angle or perpendicular to the side of the triangle. Now let's use what we are given to find the side length A. Recall, to find the distance from one point to another point, we can use the Pythagorean Theorem, also known when working with coordinates as the distance formula. For the right triangle to the right of the perpendicular line, the length is side length x minus c, and the height is simply y minus 0, which reduces to y. Note, I use point 2 as xy and point 1 as c and 0 in the distance formula. This is why it's x minus c and not c minus x. Taking the square of both sides, we are left with a squared being equal to x minus c squared plus y minus 0 squared. So now we need to find a way to relate x and y to the side lengths and angles of the oblique triangle. We can do this by using the way we solve right triangles, SOHCAHTOA. We will be concentrating on the right triangle left of the perpendicular line, so we can redefine x as the adjacent side and use a rearranged CA of b side length times the cosine of angle A. And we can redefine y as the opposite side and use a rearranged SO of b side length times the sine of the angle A. Plugging those values into the above equation, we are left with this equation. Now we must use the FOIL method to change the form of the binomial side length b cosine of angle A minus c squared part of the equation. Doing so, we are left with this equation. Notice that we can factor out b squared to make the equation more reducible. Completing this, we are left with b squared times parentheses cosine squared of angle A plus sine squared of angle A parentheses. Recall that cosine squared of an angle plus sine squared of the same angle is a trigonometric identity equal to 1. Plugging that 1 into the equation and doing a little rearranging, we are left with a squared being equal to b squared plus c squared minus 2bc times the cosine of angle A. This is one of the forms of the law of cosines. You can find the other forms by completing the same process but using a different side length. You might want to pause here and take that all in. Looking at the law of cosines on the left of the screen, we notice that the last three equations are simply the above three rearranged so that the angle is on one side. Here's a form of the equation further rearranged to allow you to simply plug and chug to solve your desired problem. I figure it'd be daunting to listen to me state out all the filled out equations to solve a triangle. So I have listed a triangle with all the values listed so you can practice solving for one of the variables using these equations. You might want to pause here and take that in. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.